How was your test? Three has got 10 and rest very bad. What was the problem?
Sir, got confused after seeing the options.
Got confused after seeing the options. Okay.
Yes, sir.
That means concept is not clear.
No, sir. Actually, sir, I
So
don't
in
know,
that
sir.
triangle one, what was the angle, sir?
Huh?
In
It
that
was right
triangle
angle triangle, no, sir.
3, 4, 5 side is given, then what is that? Right
So
angle
right
triangle.
angle
Oh yeah,
triangle.
35,
Yeah.
45. Yes. Sir, now I remembered, sir.
Sir, after the exam, I remember, sir, that it was a right angle triangle.
For that only exams are conducted, no? So that you can do the mistake and after that you will not repeat that mistake.
Yes, sir. Never ever repeat this.
Yeah. What happened to you, Abhinav? What, log out or still present?
Sir, how to know the maximum and minimum force experienced by the two charges, sir?
Distance is fixed, so its product will be minimum when minimum charge will be transferred. 1.6 into 10 power minus 9.
So
I guess Q by
minimum possible charge is the charge of one electron.
2. Yes, sir.
Okay.
So minimum charge possible is 1.6 into 10 to the power minus 19
Yes, sir. 2.3.
electron or 2 proton or 1 electron or 1 proton. If repulsion is there, then 2 electron or 2 proton. If attraction is there, 1 electron and 1 proton will be there.
The charge is going to remain the same, sir.
So charge will be same 1.6 into 10 to the power minus 19. So minimum force will be minimum possible electrostatic force, attractive or repulsive, whatever it is. 1 by 4 pi epsilon naught E square over R square, and R was given.
Yeah.
Centimeter.
1 centimeter.
One
1
centimeter.
centimeter.
It will become 9 into 10 to the power 9. 1.6 into 10 to the power minus 19 whole square and 10 to the power minus 2 whole square.
So who got full marks, sir?
Sir.
Full marks got Mohit, Anmol and Prayer.
And
Question, sir.
what is the maximum force, sir?
Maximum force cannot be. Maximum force will keep on increasing. That will
That
depend
one
on.
is Q by
Sir.
2.
No, that one when we divide, that we have already discussed in the class also.
Yes, sir. Differentiation. By differentiation.
So when we divide any charge,
Hmm.
the force between these two charges will be maximum if we divide equally. So whatever charge was given,
Okay.
we will divide equally, and whatever distance was kept, so same thing. Yes.
Sir, one more question was there. Sir, that option was there, na, both 1 and sir, that a third charge of that 90 millicoulomb was placed. That
Okay.
that question.
Let me bring the question.
Sir, plus 20 millicoulomb and minus 40 millicoulomb was there, sir. And
Yeah.
coulomb you have to keep such that plus 20 is in equilibrium.
Which option was correct? I just
So this one was two charges plus 20 millicoulomb and minus 40 millicoulomb. That one.
yes, sir.
So two charges plus 20 millicoulomb So here is plus 20 millicoulomb and other is minus 40 millicoulomb. Are placed 80 centimeter apart. In order to keep 20 millicoulomb charge in equilibrium, the third charge plus 90 millicoulomb must be placed on the same line at a distance of, okay. So where will you place plus 90 millicoulomb charge? We can't place this side.
We can place.
Millicoulomb charge, yes. If you are placing this side plus 90 millicoulomb, what will be? This will be repelled, 20 millicoulomb will be repelled, and it will be attracted by this. So due to this, both the charges will experience force in same direction. So this can't be in equilibrium. We can place somewhere here. Suppose we are placing. Then what will be? This plus 90 millicoulomb is repelling and this one is attracting. Possibility is there. Another possibility is here. Plus 90 millicoulomb. It is repelled and due to this it is attracted. So we will find at a distance x from this or from this, whatever you find. So suppose you are taking from, which one you will take? Okay, this one will be better. This one it is x. So what will be? The force due to minus 40 millicoulomb and force due to 90 millicoulomb will be equal and opposite. Opposite are there. Magnitude will also be equal. So what will be this K 20 millicoulomb into 90 millicoulomb over x plus what is the distance? 0.8 equal to this and this. 20 into 40, of course, K will be there, and 0.8 square. You may assume this side. So we'll get two values of x. So this K cancel. So this one is x plus 0.8 over 0.8 whole square will be 9/4. If we remove this square, under root. So it is x plus 0.8 by 0.8 is plus minus 3/2. So the value of x is x plus 0.8, 1.2, no, 0.8 into 3, 2.4 by 2, 1 point, okay, plus minus 1.2. So this x is how much? And this is plus 1.2 become
0.4.
plus 0.4 or minus 2.0. So one possibility is 0.4. Other is minus 2 meter. That means 2 meter from here this side. So it is crossing this line. That means somewhere here. So when we place 90 millicoulomb here at a distance of 2 meter from this place, magnitude of the force is equal, but direction is also same. So this answer will not possible or will not use. Here we have considered only magnitude. So magnitude will be equal when we are placing here. but direction also in the same. So this one will not remain in equilibrium. So in order to keep it in equilibrium, either we can place here or we can place here, this place. So if suppose answer is coming 20 centimeter only, then both answer are correct. 20 centimeter from here or 20 centimeter from this side. But here it is coming 2 meter, which is beyond this place. So that's why that option is not correct. So this one will be 0.4 meter from here and 1.2 meter from this one. That is the correct one of correct option. Yes. Over.
Yes, sir.
Now, gain in kinetic energy. When charge particle is moved in electric field. Whether the field is uniform or non-uniform, no problem. So suppose this is electric field, maybe uniform, maybe non-uniform, whatever it is, no problem. Maybe unidirectional, maybe different direction. Now in this case, suppose a particle is starting from this place Q. It means point A, charge is Q. It is moved from A to B. Okay. Then how will you find the work done? So according to work energy principle, what will be? Work done by this electric field will be equal to gain in kinetic energy. Here if we consider this external force acting on this particle, electric force is external force suppose acting on the particle, then work energy principle says work done by all the forces equal to gain in kinetic energy. That is work energy principle. So according to work energy principle, so it is work done by all the forces will be equal to gain in kinetic energy. Of object or particle, whatever it is, whatever the object or particle is, so work done by electric field. Here it is, work done by electric field only. So work done by electric field will be equal to gain in kinetic energy of charge particle. Now work done by electric field If electric field is uniform, that is special case may be different. If it is non-uniform, then how will you find E dr cos theta, or E dot dr we can say? No, QE will be, no, force will be QE.
Yes, sir.
Fs cos theta, or F dot S is the work done. So QE into dr, or dot product of these two, is the work done. If we are in from here to here longer distance, then we will integrate it. Whatever the value of R1 and whatever the value of R is varying from where to where. So this is equal to half m v square minus u square, that is again kinetic energy. So this is the general formula for work done. Now this EDR, as we know, this intensity is minus dV over dr. So this magnitude of E into dr is dV. Or so vector product also no problem. Minus dV it will come. So this E into dr, that is dV. So it may be Q dV with negative sign, we can say, will be with integration this one, half m v square minus u square. Now, as this electric field is conservative force, so it does not depend on the path followed. Whether you are going A to B in this way, or you are going first this way and after that it is going like this, or you are moving this way and then going this way, no problem. As it is conservative force, so what will be this integration of dV will be V2 minus V1. So this Q V2 minus V1 with negative sign will be, we integrate from V1 to V2. So integration of dV will be V only. So it is V2 minus V1. This is half m v square minus u square. That means this Q V1 minus V2 is half m v square minus u square. So frequently we use this relation, or we learn this relation as this charge into potential difference is equal to gain in kinetic energy, or change in kinetic energy better, because this if charged particle is moving higher to lower or lower to higher potential, so it will sometimes it will lose kinetic energy, sometimes it will gain kinetic energy. So this general formula is charge into potential difference will be equal to change in kinetic energy. That change may be gain or that change may be loss, depending on how it is moving.
Sir,
Yeah.
sir, that second line minus Q V2 minus V1 minus.
So equal to.
Yes.
Equal to. So if electric field is uniform, then this E will be outside, only integration of dr will come. So E into R also may be E into D, or from here also we can say dV means E into R. Potential difference V2 minus V1 will become E into R. So if electric field is uniform, then so dV will be minus E into R. That is, it will depend in which direction you are moving, whether you are moving in the direction of electric field. If you are moving in the direction of electric field, potential will keep on decreasing. dV will be negative. That is, V2 minus V1 will be negative. If you are moving opposite to the electric field, then dV is positive. So this delta V or dV, this V2 minus V1, or we can say integration of this, will become integration of this dr E into R. R means final position minus initial position, that is displacement vector. So this V1 minus V2 is minus E into R. That means if displacement vector R is in the direction of E, what will be? Oh, no. There will be V2 minus V1 minus PR. V2 minus V1. So this negative sign we have brought this side. Otherwise, V1 minus V2 is E into R. That also you can consider. So if you are writing V1 minus V2, then it will become E into R. Okay. So if E and R are in the same direction, what will be? Or angle between E and R is less than 90 degree. Theta is less than 90 degree. What will happen? Then this V1 will be more than V2. That means if you are moving in the direction of electric field, potential will keep on decreasing. when displacement is in the direction of electric field, electric potential keep on decreasing. Or indirectly we say the electric lines of force will move from higher potential to lower potential. Or we can say the direction of electric lines of force always point from higher potential to lower potential. If we consider, suppose this is the point charge, so electric lines of force in this direction. What is happening here? As we know, if you find the or plus capital Q, we say plus capital Q. If we bring any charge from infinity to this point, suppose you have potential of A and potential of B. So potential of A is what? Work done by external from infinity to A per unit charge. And we have to bring positive charge only. So VA is positive, VB is positive, VB is how much? Work done from infinity to B. Which one is more? Which one is more, VA or VB?
So one question.
Yes,
So what is the capital Q?
that is the source. Suppose electric field is produced due to this charge. And we are bringing this Q charge from infinity. This Q charge is brought from infinity to this point.
Sir, VA is more, sir.
V,
A is more. VA is more.
in which case we have to do
More
more work. Both work is positive only.
Yeah. Because
Because
distance will be more.
positive charge we have considered. So distance of A will be more. Here,
Yeah.
VA and VB both are positive. And this VA will be more than VB. Now you see the electric lines of force. Electric lines of force is moving from higher potential to lower potential. This is the direction of electric field. So, if electric lines of force is given, then we can know which side will be higher potential, which side will be the lower potential. Or if electric potential is known, then we can say in which direction electric lines of force will be moving. Got that concept?
Yes, sir.
Yes. Now we will come to equipotential surface. So from the name itself only it is very clear. Equipotential means potential is equal everywhere. On this surface, potential is same everywhere. That is the meaning of equipotential. So it means electric potential is same at any point of such type of surface. So it is an imaginary surface on which electric potential due to the electric field is same everywhere. So it is not real surface. We can imagine, okay, this is this type of surface. So we say it is an imaginary surface of any shape. It may be in which electric potential due to electric field is same everywhere or same at all the points or whatever you say. So it may be of any shape. Now suppose an example we are saying. If we consider a point charge plus Q, what is electric potential at distance R? One by 4 pi epsilon naught Q over R. That is electric potential due to point charge. So if we consider distance R here, or distance R this side, distance R this side, or distance R this side, distance R this side, electric potential will be same everywhere.
Yes, sir.
So if we join these points, or sometimes we call it is the locus of the points having same potential. That is also sometimes written. So it is the locus of points having same electric potential. So if we join the position of those points which have got same potential, what will be the shape? What will you get? Yes?
Circle,
Sphere type circle.
circle,
We will get
Sphere.
sphere.
yeah.
Maybe this side also, up also, down also, this side also, that side also. So we get a sphere. That means equipotential surface due to this charge will be a sphere. Now suppose at a distance is R1 and another we are considering a distance R2. What will be? So here electric potential is V1, then here it will come another equipotential surface. So it means due to a charge, we can consider so many equipotential surface depending on its potential. So at this particular equipotential surface, potential is same everywhere. At this particular sphere, potential is same everywhere, that is V2. And how much it is? This V2 is how much? 1 by 4 pi epsilon naught Q over R2. What is V1? 1 by 4 pi epsilon naught Q over R1. What went? So, due to any source, we can have any number of electric potential. Now here electric field intensity will be different, here electric field intensity will be different. As this potential is higher, this is lower. So what is the direction of electric field? So this V1 is more than V2. So what is the direction of electric field? From higher to lower. And that is the case. Electric lines of force are in this direction only. Now what are the properties of this equipotential surface? Now suppose we want to move a charged particle plus Q from this point A to plus this point B. How much work we have to do? Work done from A to B. How much it will be? By electric field or by external agent? How much it will become? So it is Q BB minus BA in case of external agent. In case of electric field, VA minus VB. By external agent, or it may be Q VA minus VB by field. Now what will be that work? How much work will be done? Yes, anyone? How much work will be done when we move from A to B? It is zero. Electric potential at point A or at point B is same. So no work will be done when we move any charged particle on equipotential surface from one point to other point. If you are moving any charge, work done will be zero. But if you are moving from one equipotential surface to other equipotential surface, work will be done. In this case, it will become Q V1 minus V2 or V2 minus V1. So from one equipotential surface to other equipotential surface, work will be done. But work will not be done when we move charged particle from one point to other on same equipotential surface. Now, what is the other characteristics of this one? These electric lines of force will always be perpendicular to the surface. If you consider here tangent, electric lines of force is perpendicular. So electric lines of force will be always perpendicular. The direction of electric lines of force will be from higher potential to lower potential, from higher equipotential surface to lower equipotential surface. Got the points? Yes. Some other properties are also given in your book. So sometimes it is asked, write 3-4 properties of equipotential surface. So these are the main properties what we have discussed. So electric lines of force will be always perpendicular to equipotential surface. If it is of different nature, then it is along that radius. Now suppose we are saying electric lines of force is this way. It is
The
uniform.
next class is going to start, sir.
Yes.
So next class is going to start.
It's 9:50.
Going to start. Okay, then we will leave. So only thing is there, if electric lines of force is uniform, then equipotential surface will be a plane surface. Because perpendicular to this will be a plane surface. Okay, so just you read the properties.
Thank you, sir.
Okay, thank you. Learn the properties of equipotential surface which are given in your book.
Thank you, sir.
Thank you. Still you are here? You don't have computer or what?
No, sir, I have biology.
Oh. Okay, thank you.